Okay, determining the amplitude of sine and cosine functions. So on this top graph, you can see a bunch of different sine graphs are all plotted on the exact same axes. So the smallest one here is the 1 sine of x. So that 1 out in front, that's where we're going to get the amplitude. All right, so you can see that that oscillates in between +1 and -1. So we'd say the amplitude for that graph is just 1. Where we move up here, we have 2 times sine of x in kind of the blue. That goes up to 2 and down to -2 on the y-axis. So we'd say it has an amplitude of 2. So as you can see, the bigger the number out in front, the larger the amplitude basically. The taller and skinnier that each one of these gets, it's going to be like a stretch of a normal graph, but we just call it the amplitude when we're talking about sine or cosine. All right. An alternate way to find this is if we have a graph given to us, we can calculate the amplitude by saying it's going to be half of the absolute value of when we subtract the maximum y value minus the minimum y value. So if we were given a graph, we could use this definition of how to compute the amplitude. All right, so let's actually put this into a practice on a couple quick examples here. So we want to find the amplitude of this sinusoidal function where f of x equals -4 times the sine of x. All right, so with that, the amplitude can be computed by saying it's the absolute value of whatever that number is out in front. So the number out in front is going to be a -4. So we're going to take the absolute value of -4, which, as we've worked with absolute values before, you can see that that's going to make it into a +4. All right, so we would say the amplitude of this function is going to be 4. It oscillates between -4 and +4. Now, is this function stretched or compressed vertically? We would say that because it's a multiple bigger than 1, we would classify that as a stretch. The other thing that's going on in this particular example is that's a negative out in front. Because that's a negative out in front, that's going to be a vertical reflection. Okay, basically meaning the original sine graph has been flipped upside down. So instead of starting at 0 and going up initially, this is going to start at 0 and go down initially based on that vertical reflection. All right, on our next one, what we have is 1/2 times sine of x. And I chose sine of x on both of these. However, you could just as easily have used cosine of x, and the exact same result is going to be happening here. So the amplitude in this situation is going to be the absolute value of that number out in front. So the number out in front this time is 1/2. So the absolute value of 1/2 is going to give us +1/2. All right, so the amplitude is going to be 1/2 based on this number out in front. But then to answer the question, has it been stretched or compressed vertically? Because this is a number between 0 and 1, we would classify that as a compression. All right, so a number bigger than 1, we call that a stretch. A number between 0 and 1, we're going to call that a compression vertically. Basically, this oscillates in between it goes up to 1/2 and down to -1/2 um, because the amplitude is 1/2. So I hope this helps out as you're trying to determine the amplitude of both sine and cosine. I know ours were sine functions, but the exact same process gets you through cosine functions. Good luck.